Okay, here we go. So, of course, we've done this already with other functions, but one of the things we could do is take the derivative symbolically using the name of the equation, and then plug in on the back end from a table or a chart. And that's what we're doing right here. So suppose that on example 7, we have the differentiable functions f and g. So again, what that means is not only are f and g differentiable everywhere, but they're also what everywhere? Continuous everywhere. So what that means is if we need it, we have the IVT on our side. And I think that's the only one we've learned so far. Yeah. Evaluate the derivatives with respect to x at the following values. So these questions are made easier if we do something else to each one of them. Let's go ahead and set them equal to y. Okay, just notationally, it's going to be a lot easier to show if it's equal to y. All right, so now that it's equal to y, before I can find y prime of 2, which is what we're interested in, that's what we want, I need to find y prime of x. And you could treat it like a function notation if you want. All right, so let's do that. I'm going to rewrite this, though, because I have 2 times f of, and it's not just plain old x, is it? So anytime you have an inside function, whether it's an actual expression or even a name like this, on the inside, something more than plain old x, it's going to be a chain rule. And we know it's on the inside because we said of. So I'm going to take 3x halves and write that as 3 halves times x, so that 3 halves is the coefficient, right? Okay, so let's go ahead and find dy dx. You know what I'm going to use? I'm going to use Leibniz notation. So instead of y prime of 2, which is equal to y prime of 2, I'm going to find dy dx evaluated at x equals 2. We need to have some experience, more practice with Leibniz notation. They mean the same thing, though. So here we go. The derivative of y with respect to x is, well, 2 goes along for the ride, doesn't it? Because it's a constant multiple. And then the derivative of f of blob is f prime of the blob times the chain rule, the derivative of the blob. The derivative of 3 halves x is 3 halves. Okay. So that would be the derivative. Now all we got to do is plug in a 2, you say. All right, so the derivative of y with respect to x evaluated at x equals 2. That's how you'd show that, equals. So we can combine our numbers now. So 2 times 3 halves, that's going to be 3. And then it's going to be times f prime of 2 times 3 halves on the inside, which will be 3 as well. And then starting a new column, I get equals, let's see, 3 times f prime of 3. This is where we finally go to the chart. F prime of 3. Please be there, right? Please be there. F prime of 3 is 2 pi. Yep, 2 pi. So, of course, you stop there on a free response, or you go ahead and multiply them out and you get 6 pi. There's the answer, 6 pi. Find the derivative as a function of x before you plug in. All right, questions on A? Nothing to it, right? All right, letter B, let's go ahead and call it y again. And we'll find the derivative of y with respect to x. So the left side is dy dx. And now we're going to use the sum rule, right? We just take the derivative of each of these separately. So it's going to be f prime of g, and then plus g prime of x. I'm sorry, f prime of g. What did I do? I was thinking of the next one. F becomes f prime, g becomes g prime. They're both still functions of x. So this one didn't require the chain rule, right? But it did require the derivative. And now we'll plug in the 3. So dy dx evaluated at x equals 3. We get f prime of 3 plus g prime of 3. And on a free response, you cannot stop there. That's not considered a numeric answer because it still has notation in it. But now we can plug in from the table. Please be there, right? F prime of 3 is still 2 pi. And then G prime of 3 is -4. So oh, that was G of 3. Ooh, I need to work on my table reading skills. It's 5. Man, boy, those mistakes can easily happen at the end, right? Yep. That would be a good answer choice on a multiple. 2 pi minus 4, right? There we go. All right. Keep on going, right? It's not difficult. It just takes a little bit of time. So we got F times G. What rule are we going to use for the derivative here? Product rule. So the derivative of y with respect to x equals, by the way, when you're taking the derivative, you don't even have to put the of x. Did you know that? You can. When you plug in, of course, you need to put like the of 3. But over here, if you just wanted to say the derivative of f is f prime times g goes along for the ride, plus f goes along for the ride, times the derivative of g is g prime. That works for the derivative. We can still consider that a function of x. F prime g plus f g prime. F prime g plus f g prime. And now at 3, we get the derivative of y with respect to x, evaluated at x equals 3. At this point, if you don't want to like write the whole thing out, f prime of 3 times g of 3, you could actually pull it straight out of the table because you've shown on the left-hand side that you're plugging in the 3. You want to try that? Let's try that. F prime of 3. Instead of writing f prime of 3, I'm going to pull f prime of 3 out of the table, and it's 2 pi. Times g of 3. Instead of writing down g of 3 and evaluate it on the next line, I'm just going to put g of 3 is from the table -4. Plus f of 3. F of 3 is 3. And then g prime of 3 is 5. There you go. And that would be about as little as you would have to write to get full credit on the free response. Okay. Of course, simplifying that, we get -8 pi plus 15. Or if it were a multiple choice answer, it would probably be written as 15 minus 8 pi. Fun and easy. Fun easy. A, B, C, and D comes next. Okay, here we are at a quotient, right? Y equals that. So before we can find the derivative at 2, we got to find the derivative as a function of x. So this is the old ho d high rule, right? Ho d high is f prime, ho d high, minus high, d ho is g prime, all over ho ho or ho squared, g squared. Now we'll plug in our old 2, dy dx, evaluated at x equals 2, equals. I'm not going to pull these straight out of the table. I'm going to go ahead and write g of 2 times f prime of 2. Now notice that I didn't include the of x on the derivative, but now when I'm plugging in a 2, I have to put, if I choose to do this line, I have to put of 2. And then g of 2, I'm going to put the whole thing squared like that, because that's the usable format. And now it's just a matter of pulling it out of the table correctly. And let's see, you can still read what I have down there. It's small, but I can still see it. G of 2 is 2. F prime of 2 is a third. That's the first time we've seen that guy. F of 2 is 8. G prime of 2 is -3. This part is not hard, but it is easy to mess up if you're not concentrating, as you already saw me do. G of 2 is 2, and then that's squared. So there's your free response answer right there. Everything's still clearly labeled. You don't need to bring down the left-hand side once you set it up, but you do got to line the equal signs up. And then we'll keep going. When you start a new column, again, you don't need to bring the left side along with you if you don't want to. You certainly can. This ends up being 2/3 plus 24 all over 4. And that would not be the multiple choice answer. So at this point, if you wanted to simplify it, you could either, work with the fractions or lick them over lick them. All right, let's see what that would turn into. That would turn into a 2 in the top plus, 24 times 3, 72, all over 12. And so now you get 74 twelfths, which simplifies to 37 sixths. Yeah, wow, okay. Fun. Purple and green, that's not a bad color scheme. Are there any college teams that are purple and green? I know there's purple and orange, which doesn't go nearly as well. Right? Who is? The Hulk is purple and green. There you go. The Joker is purple and green. All right. Part E. I'm going to switch to, let's see. How about this blue? Beefy brown. I was going to save that for beefy brown. Y equals. All right. This is F times G, right? Another product rule, yes? No. It's a chain rule, F of G of X. So before we can find Y prime of 2, we need to find Y prime of X. And I'll call it Y prime of X this time instead of Leibniz notation. You can actually use function notation on the Y equals notation, all right? It's not a stretch to be able to do that. So working from the outside in, the derivative of F of blob is F prime of the blob times the derivative of the next layer, which is G of X. That's G prime of X. And if you want, you can even go in to the innermost layer. It is just plain old X, but it works. What's the derivative of X with respect to X? 1, okay? So you don't really need that line, but you can if you want it. And now Y prime of 2, F prime of G of 2 times G prime of 2. So this one, I definitely will write it all out. And one layer at a time, F prime of, let's see, G of 2. Please be there. It is there. G of 2 is 2. Okay, boom. Times G prime of 2. G prime of 2 is -3. Dot -3. How's that looking, right? All right. There we go. I put dot negative. Now I put parentheses around it. And now I just got one more. F prime of 2. F prime of 2 is a third. 1/3 times -3. And then finally, I could stop there on a free response because finally that's numeric. Notation is in order. It looks good. But I got to keep going, right? A third of -3 is -1. There we go. Nicht so schlecht. Not so bad. All right, letter F. We got the square root of F of X. So let's call that Y equals. Got to rewrite that, dude, right? Y equals F of X all to the 1/2 power, right? Now that's going to be a chain rule. So I'll go back to Leibniz notation, dy dx. Working from the outside in, blob to the 1/2 becomes 1/2 times blob to the -1/2. And then the blob gets rewritten times the chain rule, the next link in the chain, the derivative of F is F prime of X. Good. Now, because we're going to use it, I'm going to clean it up before I plug in. So dy dx, I guess I don't need to rewrite it if it's still dy dx. Let's see. In the top, we're only going to have F prime of X. And in the bottom, the 1/2 puts a factor of 2 in the denominator. And then the F of X to the -1/2, the negative brings it downstairs. The 1/2 puts it back under the radical. Okay, so there's the cleaned up version of it. And now we can plug in a 2. So the derivative of y with respect to x evaluated at x equals 2 equals, I think I will try to pull this one straight out of the table, f prime of 2, f prime of 2, f prime of 2. 1/3. All right, that's 1/3. All over 2 times the square root of f of 2, f of 2, f of 2. 8. 8. And that is your free response answer. Yeah, yeah. Now, if you're going to clean this up for a multiple choice answer, the 1/3, you can already bring the 3 down to the bottom, right? Or you can lick them over lick them if you want. If you don't want to just bring the 3 to the bottom, 3 over 3. And of course, then in the top, 3 times a third is 1. 3 times 2 is 6. In the bottom, you don't distribute the 3 to both factors, right? We don't do that because there's just one term. It's just multiplied by 3 by any one of them. So I get 3 times 2 is 6. And then the square root of 8 doesn't simplify, does it? Or it does. It's not a perfect square, but it is 4 times 2. And 4 is a perfect square. So it simplifies to 2 square root of 2. So that becomes 1 over 12 times the square root of 2. Multiple choice answer. Would College Board necessarily rationalize the denominator? No, not necessarily. There kind of has to be a reason why we'd want to do that. So a lot of the times they won't rationalize the denominator, but sometimes they'll have a reason, which is, let's make the students do a little bit more, right? So let's go ahead and do that. So we're prepared. Let's see a different color here. How about gray? Square root of 2 over the square root of 2. I like light gray. Let's try light gray for the final answer here. Can you see light gray? No, it's too light. No. How about, I don't know. I get distracted by colors. How about dark green? We end up with 1 times square root of 2. That's square root of 2 all over 12 times. Square root of 2 times square root of 2 is 2. And then we end up with the square root of 2 over 24. Yeah. So any of those final numeric answers are good for the free response, but there's really no incentive, right, to go anywhere past that first beefy brown numeric answer on a free response. Okay. All right. How are we doing on time? 5 minutes. Okay. Plenty of time. Plenty of time. Let's do this one here. Y equals 1 over g squared of x. You want to use the Hody-High rule here? No, I wouldn't, because you got a constant multiple in the top. So let's bring that to the top and call it to the negative 2th power. And then let's write it in expanded form. Okay, expanded form so that we don't miss a layer when we're differentiating. So the quantity g of x to the negative 2th power. There we go. And now the derivative of y with respect to x is, by the chain rule, negative 2 blob to the negative 3rd. Multiply, subtract. That's still just g of x times the chain rule, g prime of x. Nice. Now, because we're going to use it, I'm going to clean it up before I use it. dy dx is, let's see, in the top, we're going to have a negative 2 g prime of x. And in the bottom, we're going to have g cubed of x. But instead of calling it g cubed of x, because I still want to use it after that, I'm going to put it still in expanded form, g of x quantity cubed. All right. And now we'll plug in the 3. The derivative of y with respect to x at x equals 3 is, and I'll see if I can go straight to plugging in from the table. So g prime of 3 is 5 all over g of 3 cubed. G of 3 is -4. -4. Parentheses cubed, right? Free response, that's it. We're done. Free response, we're done. Multiple choice, we'll keep on going. -2 times 5. Let's see. Oh, that's -10. I'm good at that. And then -4 cubed. It's going to be a negative number, right? A negative to an odd power is negative. So 16 times 4, 64. And now the negatives divide out. So I'm back to a positive number. And then I can pull out a common multiple of 2. Yeah. So we're left with 5 30-seconds. Beautiful. Beautiful. That's the slope of the tangent line of that function there. That's its instantaneous rate of change. Blah, blah, blah. Now, I'm not going to do this one here because it gets a little bit sticky, but I will show you this. All right. What's the derivative of the absolute value of x? Well, we're going to use the identity that the absolute value of x is really the square root of x squared, which is really x squared to the 1/2 power. Now, at this point, we're not going to simplify the exponents. Otherwise, you get down to plain old x. We're going to use the chain rule. It's 1/2 blob to the -1/2 power times the chain rule, the derivative x squared, which is 2x. If we clean that up, the 2 and the 1/2 divide out. We're left with x over the square root of x squared again. And what's another name for the square root of x squared? The absolute value of x, which happens to be the same as the absolute value of x over x. So it turns out that the derivative of the absolute value of x is Señor Salta. And we saw that in the calculator section. We actually sketched the derivative of absolute value of x, and it showed up as Señor Salta, 2 horizontal lines. So this identity right here, the absolute value of x is the square root of x squared. We'll use that quite a bit throughout the year. Notice it's not equal to the square root of x squared like that, because that doesn't allow negative numbers under the radical, okay? So there you go. We finished 3.6. The worksheet for 3.6, we'll make it due on Thursday, okay? The worksheet is due Thursday. I just put it in Canvas, so you do have a tray to turn it into, all right? We'll see you tomorrow on early release day, and we'll start implicit differentiation tomorrow after the quiz. Oh, it's going to be fun. It's only over chain rule, right? And trig stuff. Yeah.